Good morning, students. I'm Dr. P.S. Kaushik, Principal at Sri Digambar Institute of Technology, Dosa, Rajasthan. This is my 16th lecture on the subject engineering mechanics. Today I will be dealing with the topic of ladder friction. The subject belongs to the third semester of mechanical and civil branches. Let us know what we learned in the last 3-4 lectures. That is, we learned about friction, that mechanism of friction, type of friction, then laws of friction, then definition in friction. These definitions are friction angle, angle of repose, total friction, and cone of friction. And we dealt many problems based on inclined plane as well as on horizontal plane for a block kept on a plane, rough plane. Now, we have till now applied the conditions of static equilibrium for coplanar cone current force system, that is this. But now onwards, that is in this lecture, we will be applying the conditions. These three equations will be formed. That is, conditions are coplanar non-cone current force system. All the problems on the ladders will be based on the conditions of static equilibrium for the coplanar non-cone current force system. Take the case that is a ladder, as you know, having two longitudinal bars made of bamboo or some aluminum or steel, and number of cross bars. These cross bars are used as steps to climb up. The figure 4.35 shows a ladder. This is the ladder. You can say this will be like this. There will be number of crossbars like this. A person will climb above it like this. One, then next, then next, then next, and we will go on the top. Here we are considering a ladder weighing W kg resting with the wall, making an angle of theta with the horizontal. Here there will be a normal reaction at A and there will be a normal reaction at B. This is RB and this is RA. When the ladder is just to slip at the impending condition, the ladder movement will be like this. The ladder movement will be that this end will slip like this and this end will slip like this. In this way, you can virtually visualize that the force of friction at B will be this way and the force of friction at A will be this way. That is mu B RB and this will be mu A RA, where mu A is the coefficient of friction at A and mu B is the coefficient friction at B. Hence, how to tackle the problems? Here we have to find that at what angle the ladder should stand, that the man can climb at the top, that can be, or how at what angle, minimum angle, that ladder is not toppling of its own weight. These are the conditions which we have to find the answer for them. These are very simple problems, and you will enjoy this. Here, what we have to do? First, just find summation f x equal to 0. That is horizontal component of the forces. Here, you find this is the horizontal and this is the horizontal. Only two components are horizontal. So we can say RB equal to mu A R A. This is the first equation, horizontal component. Similarly, the vertical one, this is acting upward, this frictional force will be acting upward, and this weight of the ladder acting downward. It means summation f y equal to 0 means W minus R A minus mu B R B. This will be the equation formed here. Next is we have to take the moment about either A or B. Usually we take a moment about A. That is, the intention of taking moment about A or B is that is mu A R, this is R A and mu A R A. Two forces are going across this point, and their moment about this point will be 0. Then we will be left only this moment of this, which is clockwise, and moment of this, which is anti-clockwise, and moment of this again anti-clockwise. So balance these two, summation m equal to 0 we have to do here. So as I told you, three equations can be formed here, that is summation fx is equal to 0, summation fy equal to 0, Now take the first case. Determine the minimum angle theta at which the uniform ladder can be placed against a wall without slipping under its own weight. The coefficient of friction for all surfaces is 0.2. Refer to the figure. This is weight of the ladder downward. Now this is A point, this is B point. So RB mu A B RB, then RA these are the forces acting on this. This is figure 4.35. So first resolving forces along the horizontal and vertical, that is first RB equal to mu A RA. This is your equation number Now RA this is your first. Second one is this RA plus mu B RB equal to W. This is your second. Then proceeding further, RA equal to mu into mu A, RA taking using the equation first. This is using this equation and putting the value of here. So RA plus mu A mu into RA equal to W, or RA equal to 1 plus W upon 1 plus mu square. Now taking moment about B, we are taking the moment about this point. RA into L cos theta. This length of the ladder is L, then this is cos theta, L cos theta. When we are taking the moment about this point, this is the reaction line of action of RA, then this will be the arm of for the moment, this RA into this arm is equal to L cos theta. This and this are equal. Now this equation will be formed here, where L is the length of the uniform ladder. Substituting RA equal to W upon 1 plus mu square from here, WL upon 1 plus mu square, this is 1, cos theta equal to W into 1 upon, that is L by 2, and WL by 2 cos theta mu W upon 1 plus mu square L sin theta. The mu upon 1 plus mu square sin theta equal to 1 upon 1 plus mu square minus half, the bracket close, that is cos theta, and by calculation you will come to the conclusion that theta equal to tan inverse 1 minus 0.2 square upon 2 into 0.2, that is 67.38 degree. Now this is the second problem. 4.118. A uniform ladder of length 10 meter and weighing 20 Newton is placed against a smooth vertical wall. The wall is smooth and vertical, with the lower end 8 meter away from the wall. This length is 8 meter. The ladder is of 10 meter length. If the ladder is just to slip, determine A, the coefficient of friction between the ladder and the floor. Here we have to find out the friction mu A. Next, B, frictional force acting on the ladder at the point of contact between the ladder and the floor. This frictional force has to find out. These are the conditions. Simple problem. Refer for this figure here. That is for the ladder and various forces acting on it. That is OA is equal to 8 meter, AB is equal to 10 meter, then OB will be 10 square minus 8 square under root, this is 6 meter. So 8 meter, 6 meter and 10 meter. Okay. Sin theta, that is 6/10. this is 3 by, and इसी तरह cos theta OA upon OB. This is cos, not sin. Cos theta, that is 4.5. Resolving the all forces along the horizontal and vertical directions. Horizontal, this RA equal to since this wall is smooth, then mu b RB will be 0. Since wall is smooth, hence vertically resolving, this RA will be equal to this W. So RA equal to W equal to 20 Newton. RB equal to mu A RA. This is RB acting this way, and mu A RA is acting this way. It means these two should be made equal. So RB equal to mu A RA. Now taking moment about the and A, we have to take moment about this point here. Then see, mu b RB is 0, so not to take. Then RA into 6. This is the line of action, and this is the shortest distance. This shortest distance is 6 meter. So and the moment will be anti-clockwise. Similarly, the weight of the letter is acting in the center, that is 5 meter. Then and this distance will be 4 meter. So this is the line of action. This is the shortest distance. Then W into 4 should be equal to RB into 6. Same thing. RB into 6 is equal to W 20 into 10 by 2 into 4 by 2, that is 80. It will be same only. Okay. Then RB equal to 80 by 6, 13.33 Newton, and mu is equal to RB upon RA, which comes out to 0.667. The frictional force between the ladder and the floor will be Fa equal to mu A RA, that is 13.4 Newton. Take another problem. A uniform ladder 3 meter long and weighing 200 Newton is placed against a wall making an angle of 60 degree with the ground. The ladder, in addition to its own weight, has to support a 800 Newton weight of man standing at its upper end. Presuming the coefficient of friction between the wall and the ladder is 0.3 and between the ground and the ladder is 0.4. Make a calculation for the horizontal force P to be applied at the ground level to prevent slipping. If the force P is not to be applied, what should be the minimum inclination of the ladder with the horizontal so that there is no slipping of it with the man standing at its upper end? Now consider this problem. Very typically, very beautiful problem and typical. If you are clear of this problem, then ladder, all the fundamentals of ladder problems will be okay now. Man is standing here, weight is here for the ladder. This angle is 60 degree. Then we have to apply a force here and like this and keep it in position, to keep it in position. So total how many horizontal forces are acting? That is frictional force plus this additional force acting towards right, and the RB is acting towards left. So resolving horizontally will be P plus mu A RA equal to RB. Now at the impending condition, the direction of frictional force will be this way at the upper end here. Then when resolving vertically, we can say RA plus mu BRB will be equal to W ladder, that is weight of the ladder, plus the weight of the man standing at the top. And then we have to take the moment simply. Against, okay, resolving the forces along horizontal and vertical directions. P plus mu A RA is equal to RB. This is the first equation. Then RA plus mu B RB equal to W man plus W ladder. 20 plus 80, 100 kg, that is 1000 Newton. Considering G 10 meter per second square. Okay. Taking moment about and A, we have to take the moment about and A. Consider this. The moment for the ladder weight is clockwise. For the man, weight is again clockwise. The frictional force and this is normal reaction anti-clockwise, and due to frictional force again anti-clockwise. So equating this, you will come to know what happen next. From the W2 into OA plus W1 into DA, that is clockwise, should be equal to RB into OB plus mu BRB into OA, means -60 angle, mu B RB weight downward 800 Newton, this weight 200 Newton downward. AB from the geometry configuration, OA is equal to 3 meter, that is center below 3 cos 60. From the geometry, you can find out OA 1.5 meter, DA 15 cos 60 0.75 meter, OB 3 sin 60 2.6 meter, and then when taking moment, RB is 442.6 Newton. From the identities first and second, when putting these value here, you will find P equal to 95.70 Newton. Means the 95.70 Newton force has to be applied at the root here to keep the ladder in position when angle is 60 degree. Thus, a minimum horizontal force of 95.70 Newton needs to be applied at the ground level to prevent slipping of the ladder. If force P is not applied, let alpha be the angle that the ladder should make with the horizontal to prevent the chances of slipping. Here, what should be the angle? This angle, of course, this will be that alpha will be always greater than 60 degree. This is sure. Otherwise, ladder will slip. But what will be the angle alpha? Let us find out here. Same way we will proceed. RB equal to mu A RA, or 0.4 RA. Resolving vertically, RA plus mu B RB is equal to W1 plus W2, that is 1000. Okay. This is horizontal resolve, this is the vertical resolve. The identities will be same like this. RA equal plus 0.3 into 0.4 RB, that is equal to 1000, and RA will be this much. RB 0.4 RA, that is 357 Newton. Taking moment about the end A. Here we are taking moment about A because there are two unknowns passing through this. So W2 into OA plus W1 into DA equal to RB into OB plus mu B RB into OA. After solution, you will find that tan alpha is equal to 2378.6 upon 1071.3, that is 2.22, and alpha comes out to be 65.75 Newton the degree. So an angle of 65.75 degree is the minimum angle required to hold the ladder in position if the force is not applied at the root. This is about this alpha is 65.75 degree. That's all from my side in this lecture. Thanks for watching this video.